All right, guys, so we're now on journal 2. Remember, at the beginning of your journals, please label your journals by the entries, or it's going to be really tough for me to grade your work. Okay, so on this here, let me grab a pen for us. We're going to be labeling, you can see these 5 different types of laid out numbers by the correct terms, okay? So let's kind of play with this a little bit. I want you guys to match up the numbers by their terms. So take a moment, pause here, and do your best to match them up. Okay, so hopefully you tried this on your own, but first ask yourself, which one do you think is the one that represents whole numbers? If you picked number 2, that's correct. So number 2, you'll notice, is those positive numbers, including the zeros. So those are what we call the whole numbers. Okay, so we can cross that out. So we can get rid of whole numbers because we've already used that. So if number 2 is whole numbers, then number 1, if you guessed this right, is natural numbers. So natural numbers, as you can tell by the example that is written, is represented by 1, 2, and 3. Now you're probably thinking like, okay, it's kind of like whole numbers but without the 0. And I hope you're noticing this because natural numbers goes all the way, dates back to like our ancestral, when they were first looking at numbers and using numbers. A lot of people thought the number 0 was very taboo. Even negative numbers seemed very mysterious. So for a long time, a lot of Homo sapiens didn't use numbers like zeros and negative numbers. We really sticked with those positive whole numbers. So that's why we call them our natural numbers. Then number 3 here, let's go ahead and cross out that natural number on the list. So for number 3, you can see that now we're adding on those negative numbers. So that is what we're going to call our integers. Now, you might have heard integers before. If you've done a little bit of programming, you usually have to declare something to be an integer. So if you are programmers, you probably already know this stuff. Okay, number 4 here. So number 4, notice how I have some fractions in there, like 1/2. I have a decimal, like 0.92. And I have another fraction, another decimal. So which category do you guys think this one is? Well, if you chose rational numbers, you are correct. So rational numbers, or anytime you think of the word rational, I want you to connect this with the idea of fractions. So rational numbers are any numbers that can be written as a fraction. So that means that irrational numbers have to be numbers that you can't write as a fraction, such as pi or e, right? So pi is this number, 3.14, and it keeps going on and forever. It can be written as a decimal form, but the thing is, those decimals that keep going on, they don't repeat in a pattern. So because there's no pattern in the decimal, we can't represent that as a fraction. So that kind of sucks. Like, we can't write those numbers as a fraction, which makes it harder to write because we don't want to write 3.14 ... like all the time. So that's why we use symbols like that green symbol pi. And for e, for the number 2.718 is going to be represented by the symbol e. These symbols help us write math a little bit more efficiently. So the 5th one here is what we call an irrational number because we can't write them as fractions. And you can also think of these fractions being ratios. All right, so that really is it on our bell work here. We're just going over these definitions, but I hope you were paying attention because you might have noticed that I didn't use one of the vocabs here, and it is the real numbers. We're going to talk about that later, and it'll kind of tie in nicely with what we're going to be talking about today, which is about sets and intervals and how they kind of merge together. All right, let's go into our next. All right, so let's talk about sets. So sets in math is this idea of a collection of objects or this collection of elements that are inside the set. And we represent sets using what we call these symbols here, braces. So let me give you an idea of what a set could be. So I'm going to say, let's write an example for a set. So I'm going to make up or declare a set to be some numbers inside. So maybe I'll pick some odd numbers like 1, 3, 5. And there you can see I have 3 elements inside my set because I have 3 numbers inside my set. So I can say this is a set with 3 elements. And then, since we've learned about natural numbers, I can actually also create, a set that represents natural numbers. So natural numbers were those numbers that were positive but without the 0. So like 1, 2, 3, ... to say that's going on to infinity. I can say that this set represents natural numbers. I'll abbreviate those numbers. There we go. So that I hope it gives you an idea of like how we can use sets. So taking in this set here, let's talk a little bit about subsets. So a subset is a set contained into another set. So basically a subset is inside of a set. And so let's take that example that I declared a moment ago, like this set here. So I can say, or maybe use 2 of the elements inside, let's say 1 and 5. I just pulled 1 and 5 from that set. And so let's write an example for that. So I can say that the set 1 and 5 is a subset of that set that we just had a moment ago. Because notice how these elements also lie in the, set previously. So what I want you guys to do is get like comfortable with seeing these braces and that they mean a set. Now, I'm not going to be asking you whether, this subset is a subset of a set. That's not what I'm looking for. I want you to get comfortable on the idea of what is a set and what is a subset. Okay. Now let's get into stuff that you're going to be seeing in your packet. Let's talk about intervals. So back when you were in 9th grade, hopefully, you had a teacher that explained to you this number line. And so on this number line, they might have placed some numbers on it like 0, 1, 2, and 3. And maybe even negative ones if you go to the left, right? So the left side's typically your negative numbers, right side more of your positive numbers. But let's think about it for a sec. When I just wrote these numbers down, aren't these integers right here? Yeah, they're integers. So let me ask you the question, can you place numbers like rational numbers on here? Like a rational number would be like a half or 0.5. Yeah, you can. Because 0.5 is between 0 and 1, right? So you can find that on the number line. You can also find irrational numbers like pi, because pi is like 3.14 ... That's a number between 3 and 4, which can also be found on this number line. And when you look at the number line here, notice how there are arrows on either ends. Well, it's because this arrow is telling you that it goes on and on forever. It goes so far that it goes to positive infinity on the right side. And you might have guessed it, negative infinity on the other side. So when I'm looking at this entire line here, it is what encapsulates natural numbers, integers, irrational numbers, rational numbers, all the numbers that we were talking about. So this is what we call the real number line. So real numbers encapsulates all those numbers that we just talked about a moment ago. And there's something even called imaginary numbers, but we won't get to that until around October or so when we learn something called the quadratic function. But more on that later. So let's move on to our next slide, really using these number lines. All right, so on here I have some tables, and we're going to fill this out. So this section here, we're going to talk about bounded intervals. So bounded intervals are going to make a little bit more sense when we actually draw the graph of this. But first things first, let's take a look at these inequalities that were given here. So notice how this x is between -3 and 3, right? So x is greater than -3, but less than 3, so it has to be in between those numbers. Those numbers there are what we call endpoints. So x is bounded between those endpoints. So let's try to draw this on a graph and represent where x might be located on this graph. So first things first, draw your number line. Then place your number on the graph. Here's the thing you got to remember, you always do from your smallest number. So out of these two, the smallest number would be the -3, right? Negative numbers are typically smaller than positive numbers. So you want to write the -3 first on the left side and positive 3 on the other side. Now let's jog down your memory lane on what symbol do you use when you have an inequality sign with a line underneath it. So when it's greater than or equal or less than equal, you use a close circle. When it is a inequality sign that doesn't have a line underneath it, just greater than and less than, you use a open circle. Because when you have an equal sign underneath the inequality, you can touch that value. It equals that value, so you can touch it. So that's why we have a closed circle. But when there's not an equal sign, it means that, well, it doesn't equal that value, but it can darn well get close to that value. So that's why we use an open circle. So for this case, notice how they're both inequalities with a line underneath. So we need a closed circle for both of those numbers on -3 and +3. And now we get to shade. This is the fun part. So grab your highlighters. I'm going to grab mine. And I'm going to shade in between -3 and +3 because that's where x lies. It lies between -3 and 3. So this shaded region represents x. And that's it. So now I'm going to do that with the other ones here. Just the same thing. Remember, draw your number line. Then plot your endpoints. So that's still -3 and 3. This time around, notice how there isn't a line on that inequality sign, so you need an open circle on both of them. And then we're going to highlight the middle part because that's where x is located. Next one here, notice how the inequality sign, this one has a line underneath, so this one needs to be a closed circle, and this one doesn't, so this needs to be an open circle. So let's go ahead and let me use a different color here. There we go. So we have -3, +3, close, open. And so now when we highlight this region here, I'm going to just highlight the middle. Let me do that consistently and use pink. Okay, and then we got our next line here where it's just the opposite, the -3 and the 3, but the +3 gets the closed circle and the -3 gets the open circle. And then we're going to highlight in the middle because that's where x is located. All right, done with the graphing. Onto the interval notation. So first things first, when you're writing an interval notation, you need 2 endpoints. Well, we just said a moment ago that our 2 endpoints for these graphs were from -3 and 3. So we're going from -3, let me do this in black, -3, comma 3. So the comma is like 2, so we're going from this number to that number. So you want to know what your starting number is and what's your ending number. Your starting number should definitely always be smaller than your ending number. So notice how -3 is smaller than 3. And what you want to do is now figure out, do you need to use brackets or parentheses? So anytime you have a closed circle or inequality signs with lines underneath, you should always use, my bad, I think I drew parentheses, should always use a bracket. When you are doing an open circle or inequalities without a line underneath, it should always be a parenthesis. So I need brackets on both sides. There we go. I'm going to do the same thing with the other one. So notice that the endpoints are also -3 and 3. And then I need parentheses on both sides. My bad. All right, and then the next one here, the third one, -3 to 3. But I need a bracket on the -3 because that's closed, and parentheses on the other one. And then this one here needs a parentheses on the -3 and bracket on the 3 because this one's an open circle, so parentheses, closed circle, bracket. All right, let's now look at the unbounded one here in the next slide. But just so to clarify, when you look at this graph here, you'll notice that the highlighted region is always bounded between two finite numbers, right? These graphs were all bounded between a -3 and 3, which are finite numbers. When we talk about something called unbounded, you'll notice that one side is not quite a finite number, and we're going to discover what that is going to look like. So stay tuned for the next slide. So let's look at unbounded intervals, and this problem probably looks a lot easier to you guys because you're probably like, whoa, it looks like x is missing a number compared to the other ones. Well, we're going to see how we're going to handle that case. So taking a look at this one here, it says x is greater than or equal to 2. So first things first, just like before, how we graphed, got to have that number line. Plot that number. The only number here is that 2. Do I need a closed circle or open circle? We said that inequalities with a line underneath needs a closed circle. So I bet you need, you betcha I need a closed circle right there. Okay, so now what we have to know is which way do we highlight? Do we highlight on the right side or do we highlight the left side? Well, the inequality says that x is bigger than or equal to 2. If it's bigger, the numbers are going to be bigger on this side of 2, right? More positive are going to be bigger numbers. So we're going to highlight that region. So we're going to highlight this region. So we're going from 2, but hold up a second. This side here has an arrow, and I highlighted that region. And so it's this highlighted part with an arrow is pointing towards positive infinity. And that means now you can see I know what my other endpoint is. It's infinity. This is going from 2 to infinity. So now I could probably write an interval notation for that. It's probably going to be going from 2 to infinity. I need a bracket on the 2. But here's the thing. Anytime you have an infinity, what do you think I need here? A parentheses or a bracket? So think about it for a sec. Can you ever touch infinity? No. Infinity goes on forever and ever. So in this case, anytime, if you want to make a note of this to yourself, anytime you have infinity or negative infinity, you should always use a parenthesis. That, by the way, is just an arrow that I like to draw, but you should always use a parenthesis anytime you have positive or negative infinity as a bound. So I need infinity right there. I'll make another line here. And so in this case, I'm going from, I got 2, but now it's an open circle. Remember, we talked about inequalities without a line. It needs an open circle here. So I'm going to highlight that region from 2 to, it's also going to infinity because x is bigger than 2. So I need infinity here. I'm going to highlight this region. Let's try to do that consistently. There we go. All right, so this time around it's the same problem, but it's just 2 to infinity with a parentheses on the 2 because it's open and a parentheses on the infinity because infinity always uses parentheses. So I'm going to go ahead and graph the other two and then write my interval notation. Might be just be a little easier. So this one here is a little different. It says x is less than or equal to 2, meaning x is smaller than 2. If it's smaller than 2, that means it's going to be on this side of the interval because those are numbers behind 2 or smaller than 2. So in this case, I'm going to shade in this region. I keep grabbing the black marker. Excuse me, guys. I'm trying to grab that pink marker. Okay, so we notice it's pointing to the left on the arrow side. So that means it's heading towards negative infinity. So this is the part I want you to be cautious of. When you write this as this interval notation, make sure you write this from negative infinity to 2 because remember, order matters. When we read math, we always read left to right because with a number line here, you want to make sure you're going from least to greatest. So negative infinity is least, and the greatest number here is going to be 2 in this case. So I need a bracket on the 2 because that's closed, and I need a parentheses on the negative infinity. Okay, one more graph here. So I need an open circle on this 2 because this has no line, and x is still less than 2, so it's going to be in this region here to the left. So I'm going from negative infinity to 2, parentheses, parentheses. Okay, so that's all the graphs. But I want to show you one thing and see if you were really paying attention and putting everything together. If I had a graph like this and I were to highlight everything on the graph, like this, how can I represent that as an interval notation? So take a moment to think about this. So hopefully you notice that because you highlighted everything, on the left side here, it's going on and on to negative infinity. And on the other end here, the right side, it's going on and on to positive infinity. So those are only two endpoints. So we're going from negative infinity to positive infinity. And I need to put my bounds there, and I have to use parentheses because they're infinity signs. Okay, I hope you hanged in there pretty well. We have one more slide to go, and then we are done. Okay, last slide here. Let's talk about set builder notation. So we're bringing in the idea of sets, and we're bringing in those interval notations and kind of combining them. But let's talk a little bit about set builder notation. I know the first time you're going to see this notation, you're going to be like, whoa, what is Miss Chang throwing at you? But it's not as scary as it seems, and I'll break it down, and we're going to dissect this symbol together. So this notation uses symbols to define a set in terms of properties of the members of set. So basically, we learned in the earlier slide that braces mean the set or a set, right? That's what we learned in our vocabulary. X is going to represent all the real numbers for x, or all real numbers x. This vertical line actually means something. It means such that. So right now, it's like it's saying the set all real numbers at x such that. So in translation, that just means like here in this set, x can only be this. Or in other words, like in this set, x can be anything except we're going to figure out that this statement here after the vertical line, so after this vertical line here, you have what you call the condition statement. So the condition statement is basically what x also needs to be. So sometimes x is not all the real numbers on a number line. It might have a few conditions that go along with it. Like for this one here, it says that x, so the set x, all real numbers, such that x is less than b, where b is like some sort of number. So let's try out some problems where we look at some of these set builder notation. We're going to make a graph, another number line graph, and also write the interval notation. But let me just stress here, the only thing you really care about when you are using a set builder notation is really just the conditional statement. That's all you're really going to look at. And we learned the other day in the journal 1 that this symbol here, the equal sign with a slash in it, means that it does not equal. So x does not equal 5. So let's draw us a number line. And the only number they gave us was 5. And so when x doesn't equal 5, do you think we would use an open circle or a closed circle? Well, if you guessed open circle, you are correct. Because x can't be 5, it can't touch 5. So you want to use an open circle. Think of 5 on the number line being this like black hole, and like anything that goes in just like disappears. But you can get really, really close, but not be in that hole. So in other words, we are going to highlight all the other region that are close, that are not 5. So that basically means that we have this left side and we have this right side. Notice how I highlighted 2 separate regions because that open circle kind of separated them. So in this case, on this side, we're going from negative infinity, and then the other side, we're going to positive infinity. And so I have 2 highlighted regions, which means I have 2 intervals that I need to write. These 2 will be my first endpoints, negative infinity to 5. I need a parentheses on the 5 because it's an open circle, parentheses on the infinity because you always need a parentheses on the infinities. And then 5 to infinity for the other side. I'm talking about this side here, so it's going from 5 to infinity. Parentheses on the infinity and parentheses on the 5. But hold up, we are not done. We need to write u, this big U in between the interval, because this U represents union, so that we can join 2 intervals together. So anytime you have more than one interval, you need to join it together with this symbol here, union. All right, we're going to do the same thing with our last final problem here. So like I said, you want to just look inside of the set builder notation, but just look at that conditional statement here. So we got a lot more conditional statement in this one. So let's go ahead and draw that number line. What are the 2 numbers that are only on this conditional statement? Well, that's -2 and 3, and hopefully you know by now that we got to plot that -2 first on the left-hand side because it's smaller, and then +3 on the right-hand side because it's bigger. Okay, from here, let's put in our closed circle and open circle. So at the -2, there's an inequality with a line underneath. So I need a closed circle. I need an open circle on 3 because that doesn't have a line underneath, so it needs to be open. Now, let's think about where we're going to shade. So I'm going to do this in color code so that way you can kind of really see what's going on here. I want us to look at this one separately from the other one. So I want us just to focus on this statement right here. It says x is less than or equal to -2. So here's -2. Numbers that are less than -2 are going to be going on the left-hand side. They're smaller. So x is smaller than -2. So I'm going to shade in the region that's smaller than -2, which is this region. Aha. So that region there is going from negative infinity to +2. I can write an interval for that, and I will here in a sec. Let's focus in on the other side here. This side here says x is greater than 3. Well, if x is bigger than 3, then you need to be highlighting the region that is on the right side of 3, because those are numbers that are bigger than 3. So x is going from 3 to positive infinity. So now we just have to represent these highlighted region or shaded region. So this region here is going from negative infinity to -2, negative infinity to -2, parentheses, bracket on the 2. The other one here, we're going from 3 to infinity. So I'm going to write a 3 to infinity, parentheses, and then that's not a very good parentheses. Let me do that again, parentheses. And then I need the U. Hopefully you caught me on that. So make sure you add in the U between the intervals to state that these 2 intervals are joined together. And that's it, guys. So try out page, so the packet 1, try out page 1 now in that packet. And remember, the key is up on that spreadsheet in Google Classroom. So check that out if you're not sure if you're on the right track. And that's it, guys. So hopefully this helps you out. And yeah, that's it. I'll see you guys next time in class.